Valves 101. Valve Basics, Types and Standards. The content of this presentation are intended for educational purposes only, and do not replace independent professional judgment. They do not constitute advice and should not be relied upon in making or refraining from making any decision. Statement of fact and opinions expressed are those of the speaker alone and are not the opinion or position of his employers, past or present, nor those of the professional bodies and committees in which he participates. What is valve? A valve is a device that regulates, directs or controls the flow of a fluid by opening, closing, or partially obstructing various passageways. Valve functions stopping and starting fluid flow, varying throttling the amount of fluid flow. Valves are grouped by how they close on the seats. Manually operated valves, 1. Closing down valves, globe, Y-pattern globe. 2. Slide valves, wedge, slab, parallel slide gate. 3. Rotary valves, ball, plug, butterfly. 4. Flex body, pinch, diaphragm. Automatic operated valves. Flow or pressure makes the valve operate. 1. Check valves, swing, tilting disc, lift, dual plate, ball check, non-slam check. 2. Pressure relief valves. Valve types. These are the common types of valves discussed: gate valve, globe valve, check valve, ball valve, butterfly valve and plug valve. The main valve components are body, bonnets, trim, packing and seals and means of operating the valve. We want to contain the medium within the pressure-containing parts of the valve to prevent leakage to atmosphere and leakage downstream when in the closed position. In the next few slides, we will discuss the body bonnet valve trim such as discs, seats or seat rings, stem packing and valve operator.
Valve body. This is the pressure-containing component. Valve body materials range from cast iron to forged alloy. The selection of the valve body depends on the function and application. The valve body is the main component in which the media flows. Hence this area is very critical in nature of the selecting the right metal for the required process conditions. The pressure, temperature, fluid flow and application criterias are very important in selecting a correct metallurgy for a valve body. Bonnet. The bonnet is the cover for the opening in the valve body. The features of the bonnet are: bonnet is the second principal pressure boundary of a valve. It is cast or forged of the same material as the body and is connected to the body by a threaded, bolted, or welded joint. The attachment of the bonnet to the body is considered a pressure boundary. This means that the weld joint or bolts that connect the bonnet to the body are pressure-retaining parts. Valve bonnets, although a necessity for most valves, represent a cause for concern. Bonnets can complicate the manufacture. Increase valve size. Represent a significant cost portion of valve cost. Bonnets are a source for potential leakage. Valve trim. The internal elements of a valve are collectively referred to as a valve's trim. The trim typically includes a disc, seat, stem, and sleeves needed to guide the fluid. A valve's performance is determined by the disc and seat interface and the relation of the disc position to the seat. Because of the trim, basic motions and flow control are possible. Disc. The disc is the third primary principal pressure boundary. It provides the capability for allowing and stopping fluid flow. The disc is a pressure-retaining part. Discs are typically forged and, in some designs, hard surface to provide good wear characteristics. Most valves are named, in part, according to the design of their discs. Seat or seal rings provide the seating surface for the disc. To improve the wear resistance of the seal rings, the surface is often hard-faced by welding and then machining the contact surface of the seal ring. The stem connects the actuator hand wheel and disc, is responsible for positioning the disc. Stem designs fall into four basic categories: rising stem with outside screw, rising stem with inside screw, non-rising stem with inside screw, sliding stem. Packing. It is used to prevent leakage from the space between the stem and the bonnet. The operator or actuator Operates the stem and disc assembly. An actuator may be operated manually or automatically.
Valve end connections. Threaded ends used for small application up to 4-inch. They are cheap but can be stripped and leak, for this reason they are used when leakage is not a problem. Threaded ends should not be used with corrosive processes, since the threads can either fail or become inseparable. Valve end connections. Welded ends. When zero leakage is required for environmental, safety, or any efficiency reasons, the piping can be welded to the valve, providing one-piece construction. Many users insist that high-pressure application requires a permanent end, especially if they involve high temperatures. Flanged ends. The most expensive but are the best from an installation and removal standpoint. The main advantage of flanges is that the valve can be removed easily from the line. Full or reduced port. Certain categories of valves can be designed with full or reduced port, example ball valve. Full port. The port diameter is similar to the nominal diameter of the pipe. It is often used when low pressure drops and pigging is required. Reduced port. The port diameter is usually reduced to the next pipe diameter down. It saves cost due to lighter weight and lesser materials used. However, it increased velocity and has a higher pressure drop. The wear is excessive wear on the seats. The noise in the system also increases. It also increased closing torque of valves when the velocity increases. Plug valve or lift checker of cross-flow. Valve packing, stem seal. Selection criteria of the valve packing is based on service medium, operating pressure, temperature range, size of packing, valve stem, and stuffing box material, availability for maintenance, purpose of valve seals, seal between seat and closure element to prevent downstream leakage, seal around stem to prevent atmospheric leakage, seal between pressure-retaining valve components to prevent atmospheric leakage. End of module. Chapter 1. Valve definition and components.